Hi, today we're going to be learning about the distributive property from Chapter 7, Lesson 2, and it's a familiar property. It may have been a confusing property, certainly more confusing than some of the other properties of multiplication that we studied. Yeah, you use it all the time when you multiply a double digit by a single digit number. The algebraic definition of the distributive property is that if you have two things that are being added and they're multiplied by another single factor, you can multiply them separately by this factor, let it be a. So you can do a times b and add that to the product of a times c. So when I talked about doing double digit by single digit multiplication, you basically do, this is like 30 plus 4 multiplied by 6. So you do the 6 times 4 part first, and you wouldn't probably write partial products like this, but you could. Then you do 6 times 30, and that would be 180, then you add them together. We use a little different algorithm where you would say 6 times 4 is 24 and add them together, and 6 times 3 plus 2 gives you 204. It's just a variation of the distributive property. A nice way to think of this that might make sense to you is if you have this b plus c, and you're going to multiply both of these by a, you put the a down here, you could say it's a times c. Then you do a times b, and you add them together, and you end up with something that looks just like that. Basically it says, if you can't simplify these two add-ins, you can multiply them separately by this factor. So, another example of this would be if you have 3 times x plus 4. You can't simplify this any further, but you can do the multiplication. You can do the 3 times the x and the 3 times the 4. And when you do 3 times x, you can kind of draw a arrow like this if you want to. You're going to distribute the 3 or hand it out to both the x and the 4, and that might be where we get the name distributive property. So 3 times x we write as 3x plus 3 times 4 is 12. So that 3 times, we say the quantity x plus 4, something that's in parentheses, we group it together as a quantity. So it's 3 times the quantity x plus 4, which is the same as 3x plus 12. It's probably tough to really get it, just to do a few more examples. And these are from your book. So if I don't make any sense to you, read it in your book and maybe that will. You can distribute the 5 to the x minus 3 as well. You're going to be 5 times x, 5x minus 5 times 3 is 15. So if you simplified 5 times the quantity x minus 3, the result would be 5x minus 15. If you did x times the quantity x plus 5, you can't do anything here. So it's just simplified. So you can do x times x, which would be x to the second power, plus x times 5, and we don't want to write it this way. We want to write the number, the coefficient first, plus 5x. A steady stream of examples here. If we have 3x as the factor, and there's nothing wrong with having a combination of things here. It doesn't have to just be 2 add-ins. It can be 3 things combined with addition or subtraction. So this would be 3x times x, should be 3x to the second power, minus 3x times 2y. 3 times 2 gives us 6. We represent x times y as xy, plus 3x times 3, and 3 times 3 gives us 9, and it's x. And just another way to look at that is it's 3 times 3 times x. That's the, let me rewrite that, it's not clear. It's 3 times x times 3, this times this, which would be 9x. Now I want to give you an example of one that can be somewhat confusing. We have this. Let me give you an easier example before I try the more complicated one. If we had just numbers in here, there's nothing wrong with doing the 5 plus 3 part first. In fact, it's very easy to do that. That would be 8, and this would mean the opposite of 8. So this would be the opposite of 8 represented as negative 8. I can, and this is going to be a helpful tip for you, put a 1 out here and think of it as being -1 times 5 plus 3. And this is where I'm going to use the distributive property to prove that I'm still going to get -8 if I use a different approach to this problem. With the distributive property, without combining these, which I could do, and that would make the most sense, is just do 5 plus 3, and then 5 plus 3 times -1 is -8. I could say -1 times 5 is -5, and add -1 times 3 is -3, and that's -8. So what all this is about is if you get an expression that looks like this, it can be kind of difficult to simplify this the right way. But something that will help you get it right is to put a -1 here. This would equal -1 times 3x minus 2. And then you can apply the distributive property. But then there's the double whammy of having this subtraction symbol and then knowing quite how to interpret that. But just kind of follow the rules. This would be -1 times 3x, and that would be -3x minus -1 times 2. This is not minus -2, it's minus +2. So -1 times 2 would be -2. And you can leave it like that, or you can change it to add +2. It's the same as the opposite of 3, or -3x plus 2, which is a little cleaner looking. And if you had to combine other things with this, is what you're going to get in a couple of lessons. What this is all leading to is use the distributive property to simplify longer expressions, and there might be more attached to this. Like we could have this with the distributive property plus 10 minus 5x. So you have to simplify this and then add 10 and then subtract 5x. But that's coming up in a couple lessons. So that's really what you need to know about the distributive property, being able to simplify using the distributive property.